This will be a pretty quick overview of some of the off flavors that come from brewing. And one of the first ones that we're going to focus on is the off flavor that you might get from just your barley, so your grain. Oftentimes the enzymes that are used to break down those long starches into smaller sugars that can be used by the yeast, those can break down during this process. And if you don't boil them off, you can create a flavor that's called the dimethyl sulfide can form. And that's why you want to take the top off of your pot, because you want that to volatilize. You want that to leave and get boiled off. So about an hour long vigorous boil helps to reduce that flavor profile in your final beer product. Hops are used for a number of reasons during the brewing process. One of them is to impart different flavors, and another is that there are some antibacterial properties for some of these compounds, so they help to reduce bacterial contamination. One of the things that we get out of hops are these humulones, and these are these big, chunky, organic compounds that are released from the leaves of our hop plants. Now, the longer typically that you boil, the more bitter that hop plant will give you those flavors, and that's the bittering component. And then there are also additional hop flavors that are smaller that you might get later if you wait until you've cooled down your wort, and then or dry hopping. That's another term that's commonly used, and you'll get these smaller compounds that will be released. And if you put these in, these are there earlier as well. The problem is when you're boiling them, they break down or they get volatilized and they leave your brew, just like that dimethyl sulfide. So these will leave if you boil really heavily. So that's why these are some of the dry hopping or the hazy kind of flavors that come out of different types of IPAs. So you'll get these in the various different types of hop flavors. So these aren't off flavors, but just different components. There's this component flavor that you may hear at some point. It's called hop creep. And that's when some of these flavors get more oxidized if they're left in your beer too long. They can cause some other off flavors that will form. And this usually happens with IPAs, very highly hopped beers with a lot of these different components in them. Yeast is another place that we get some flavors from in terms of the brewing process. And these different types of yeast can give us a lot of different flavors. So here's just a big list of some of the yeasts that are available. You can order these online. They'll ship them. You'll get them in the mail. You can pitch your beer and they'll have different flavor profiles. So if you were to use one yeast with the same barley, the same hops versus another yeast, you're going to get a lot of different flavors. So this is just a cartoon image of what a yeast cell looks like. You have all of these different inputs. So you have the sugar and different amino acids and proteins, and they'll release a lot of different components that are going to give you various flavor profiles. So remember, we're starting with these malts and different kilned versions of that. The starches in these malts are broken down by enzymes into smaller components, and then the yeast take these up and then they release these various different flavors. So depending on how healthy your yeast are and the version and type of yeast you have, they'll take these and they'll do different things with them. So some of these are good flavors, some of these could be off flavors. It depends on the amount and the threshold and the type of beer you're trying to brew. What happens is the sugar, as it's put in here initially, we have a really fast, robust fermentation ideally, where the yeast are in here eating those sugars, and we're creating these different kinds of flavors. This happens until we have a flocculation where the yeast kind of all fall to the bottom. All of these easily accessible sugars have been consumed, and there's ethanol, malic acid, acetic acid, and lactic acid. And then usually we remove those cells that have fallen to the bottom, And just the kind of floating ones, the healthy ones that are in top, continue to take on some of these compounds and cleans up the beer. And this is called a secondary fermentation. So typically additional flavors can develop, and then some of these, so for example, this is a green apple type of flavor, which isn't necessarily bad depending on the type of beer, but it just indicates that you maybe stopped your fermentation a little too early. We want that to develop into other, maybe lactic acid, or different ethanol into acetic acid. It changes those flavors a little bit in terms of what you want it to taste like. I should mention that flocculation, again, I mentioned it goes to the bottom. That's if you're working with ale yeast. If you're working with lager yeast, those actually rise up to the top and form a barm. So it's the same idea. They're kind of combining each other together. And it just depends on if you're making an ale or a lager. And typically ales are fermented at much lower temperatures than lagers, and that's going to give you different flavor profiles. Typically lagers are very clean. You don't have many of these other flavors being developed in your beer. A lot of times if you have yeast, if your yeast is not very healthy, you can kind of see also just the comparison between what glucose looks like and malic acid. There are small changes that happen that are going to be made to develop these flavors. So depending on the amounts and the concentrations, these can definitely be considered off flavors. So this could happen if you have maybe feeble or short boiling, and maybe you have some yeast that gets in there that's not necessarily the yeast that you're pitching. You have low temperature fermentation if you're in an ale and it's just too low for the yeast to be healthy and happy. Maybe you have sick or bad or dying yeast. Or you didn't wait long enough for these other compounds to get retaken up by the yeast to be made into ethanol or to take these out of the solution. One flavor that is not supposed to be in any beer typically is this diacetyl. It's this kind of buttery type of flavor. This is definitely a fault in all beers, and this again can be typically related to yeast health and the ability to take these up and to not produce diacetyl. So if your yeast are healthy, they should take these up, and this should not be made. But if they're not healthy, it might only get converted to this and then released back into your beer. So here's a list of different flavors, and a lot of times associated with the different yeast that you're using. We have acetaldehyde is typically also a kind of a green grass flavor, just like in the last slide we had the malic acid. And we have acetic acid, it's kind of a vinegar, typically is brought in by bacteria or wild yeast that are releasing that or not cleaning that up. Lactic acid is more of a sour milk or beer spoiling bacteria can cause these. But sometimes this is a good flavor. These are okay to have if you're talking about a sour beer. These would be in there. Here's the diacetyl or the 2,3-butadiene. That's again typically from, it's a buttery kind of flavor and typically associated with sick yeast health or microbial contamination or incomplete maturation, and then maybe exposing your beer to oxygen can cause this as well. Isovaleric acid is cheesy, sweaty sock flavor. Sometimes using old hops can cause this flavor as well. And sometimes it's from bacterial or wild yeast fermentation. Isoamyl acetate, this is actually a banana pear flavor. And sometimes you can think of it maybe a kind of clove flavor. A lot of times Weiss beers, German Weiss beers, will have this type of flavor profile to it. So that can depend on yeast type or yeast health as well. And finally, the dimethyl sulfide I mentioned about this flavor of cooked corn or vegetables, and usually due to improper wort development during that boiling process. Bacteria can be good for your beer depending on the style of beer. For example, you might actually inoculate your beer with a type of bacteria that's shown here. And this would be something that we probably actually won't see down in Munich, but you might see in Berlin. It's called the Berliner Weiss. And this beer is actually this bacteria on that cells This is going to be something that we would actually find on the barley, on the grain. So the way that to inoculate this, a lot of times the German brewers would make their wort, and then they would put back in some of their dry grain, and they would inoculate it with this lactobacillus bacteria, and then this would create lactic acid. It would sour the beer, and then you'd start with a sour wort, and then you'd boil that and hop that and make your beer afterwards. So this is a way that Germans can actually still make a sour beer with all of the Reinheitsgebot ingredients, which would be the barley, the water, and the yeast and the hops. So they're able to make sour beers like that Berliner Weiss with under that purity law still. But you can also buy these types of bacteria if you want a clean culture to make sure that you're not inoculating it with some other non-desirable bacteria. During the brewing process, there are a lot of ways to bring in different, even though with those few simple ingredients, you can bring in different types of compounds. So if we're bringing in yeast to do fermentation, we have a lot of variations there. We might bring in bacteria right after mashing, right after we make our wort. We bacterial induce that lactic acid flavor to make a sour beer. And then you could make all of your beer the rest of the way. That would be kind of a Berliner Weiss. And a lot of beers that we'll be looking at, or some at least when we get to Belgium, they actually introduce bacteria later after the beer has been made in oak foeders or barrel aging. A lot of times these will be inoculating the beers a second time after the alcohol has been developed to create different types of flavors as well and to re-ferment some of this. So other yeast, other wild yeast and bacteria may be present in this barrel aging process that can change the beer as well. So lots of different parts of this process that can change flavors. Sometimes these are good, sometimes they're bad. It just depends on the style and the type that we're talking about. I mentioned in class some things are good, some things are bad. You might not want goat milk kind of flavors in your beer. The hydrogen sulfide, sulfur kind of is a pretty strong flavor that you would notice. Butyric acid or vomit, definitely not good. Isoamyl acetate depends on the type of beer again. And cheese, dirty socks, typically not something you want in your beer, but depends on the style, I guess. Maybe you do want that in there. So it's again all of these different ways of doing things and creating different things that people may or may not like. This is just a article that I was looking at in terms of all of these different types. These are all different types of bacteria. So the complexity of different oak barrels. And so lambic beers are typically where we'll see some of those in Belgium. And some of those are, you can see all of these different types of barrels that have different components. So this is basically a little chart that's showing you how much of these bacteria were found in these barrels. So these barrels will have a lot of the capacity to provide different, more complex flavors on the back end. And typically, barrel aging develops a lot of really good beers, but again, you have to like that style. Some of these barrel aging flavors might be coconut, vanilla, caramel, clove, smoky flavors, maybe smoky bacon flavors. It really depends on the type. If you're making a porter, maybe you want some more of these burnt smoky flavors. Some of these, vanilla is good, caramel. So a lot of these are more typically desirable for darker beers sometimes. But again, when we're looking in Belgium, you'll see a lot of sours that will also be oak flavored, so oak barrel aged. So that's also going to provide a lot of different flavors. So these are actually from grapes and wines that they're looking at these flavors and looking at the chemicals in there. So these are also flavors that will develop when you're aging wines. And so a lot of the bacteria are going to be shared. Oftentimes, brewers and vintners or people that make wine will share their barrels. And a lot of times brewers will also share their barrels or get barrels from whiskey makers, for example, or bourbon makers or tequila or whatever. All of these different barrels will have different flavors in them and they can swap around. So a bourbon barrel aged stout might be taken from, Jack Daniels or from wherever you like your bourbon, you can get and you'll notice those flavors will be in that beer. So there's a lot of interesting things that are happening in the brewing and venting and distilling world here in the barrel aging. Just a few other types of flavors. This is kind of a peat or peat-like flavor, almond. You have different types of eugenol, which is kind of a clove flavor, and vanilla. These will all come from aging process as well. Some off flavors for aging and processing. Ethyl hexanoate, it depends. Again, these can be like anise and apple. It can be a fault if it's too kind of much like fennel. If it's more like green apple, that's less of a concern. Trans 2-nonanol is kind of papery. It tastes like you're eating paper. It's not a good flavor. And it's usually an issue with oxidation, which means that it's opened up to the air for too long, somehow got exposed. Again, it tastes like cardboard or paper. It's not a good flavor. So the next time we meet in terms of our chemistry portion, we're going to look at trying some of these flavors. So I have food grade compounds that I'll spike into some of our non-alcoholic beer, and you can see the thresholds here. I mean, these are kind of arbitrary numbers for you, but you can just see how, in terms of at least recognize acetaldehyde, you need about 10 milligrams per liter to be able to taste it. Sometimes, like lactic acid, you need 10 times more, right, even to perceive that taste. Diacetyl, you don't technically need that much. You only need 0.1 milligrams versus 10. So there are variations in how well we're able to perceive this flavor, and that will dictate, in terms of if it tastes good or sometimes if it tastes bad. If we have too many, for example, this barnyard flavor, at a really low concentration, it might be okay. But if we get up to 10 micrograms or 20 micrograms per liter, then it's going to start tasting pretty bad. So that's all I wanted you to kind of go through for this kind of component of off flavors. Once we do that sensory experience, I'll bring these things up and we'll continue to talk about it. But I just wanted to get through some of that science and have you take some notes on this so that we can continue to learn about beer and the process of creating it.